dear students, welcome you once again in our online classes. Dear students, I hope you all enjoyed your holidays and you all are happy and healthy in this pandemic situation due to coronavirus. So, dear students, in this class we will not take a heavy topic to discuss. We will take a small topic which is very easy to take you on the track to do proper study after a long break. So students, if you can remember, in the last video, in the last online class we were discussing about gravitation. So again we will start the same chapter to the next topic, but before taking next topic we will take the topic previously we took once again. So let's start chapter number 10. Chapter 10, and it was gravitation. So in this chapter, last time I told you universal law of gravitation, and there we defined the universal gravitational constant capital G. As well we found their SI unit and the dimension SI unit of the universal gravitational constant capital G. So let's have a quick review of the same topic once again. I told you, and Newton, Sir Isaac Newton, very first discovered gravitational force exerted on the bodies due to Earth. So he gave a universal law of gravitation in the reference of all the topic in the universe by generalizing the observation he observed in case of Earth and any other object. He said if two objects A and B, suppose of masses m1 and m2 are separated by distance r, then in that case the force of attraction, gravitational force of attraction experienced by these two bodies A and B is directly proportional to the product of their masses, means F directly proportional to m1 into m2, and inversely proportional to the distance of separation of the objects. So distance of separation is r, so square of distance of separation inversely proportional to. So in this way we are having F directly proportional to product of masses m1 into m2, inversely proportional to the square of distance of separation, which is F directly proportional to 1 upon r square. In this way, if we are combining these two, you can remember the same thing we learned in the last class when we took F directly proportional m1 m2 over r square. So if we remove this proportionality sign, then we have to introduce a proportionality constant, and here this proportionality constant is capital G. So F is equals capital G m1 m2 over r square. This is mathematical form of universal law of gravitation. So in this way, if you state this universal law of gravitation, then simply you can say force of attraction between any two materialic object of masses m1 and m2 separated by r is directly proportional to the product of their masses and inversely proportional to the square of distance of separation between the masses. Here this G is a universal constant. It means what? Its value is not going to change anywhere in the universe. And Henry Cavendish, British scientist, was the first who got the value of universal gravitational constant capital G, which is equals 1.673 into 10 to the power minus 11 Newton meter square per kg square. So clearly here, if we talk about the SI unit of the universal gravitational constant G, then it is Newton meter square per kg square. Last time we all took this. If we define universal gravitational constant G in terms of gravitational force F, in that case, if we put m1 equals m2 equals unity, as well r is equals unit distance, in that case we can have F equals G. So if we put this mathematical expression in statement, then we can say the numerical value of capital G are, in other sentence you can say universal gravitational constant capital G is numerically equal to the force of gravitational force of attraction between two bodies of unit masses separated by unit distance. So this is the numerical value of G, numerical definition of G. So numerically you can define G like this. So this is all what we discussed previously. And now our next topic is to take free fall motion. So we are going to take next topic, free fall. Free fall. Our next topic, free fall. So before understanding, before discussing about the free fall, let's consider an activity in which you have to throw a stone vertically upward, and you have to observe the motion of this stone thrown vertically upward. So if you throw a stone vertically upward, then this stone raises up to a certain height, which is maximum height, and at the maximum height its speed going upward is zero, as well as coming downward is also zero. It means what? This stone at highest point is not going above as well as down, so we can say it is at rest. So what happens when we throw a stone vertically upward? It raises up to a certain height, which is maximum height. At maximum height its velocity becomes zero, and after that what happens? This returns to the ground. But the thing to be noted is that while returning to the ground, what happens to its velocity? As you were saying, at highest point its velocity is zero, but as it goes down, its velocity, magnitude of velocity actually, which is speed, continuously increases, but direction remains constant. Means it is going vertically downward, direction is not changing, but the magnitude of velocity, which is speed, is continuously increasing, continuously changing. If the speed is continuously changing, then we can say velocity is continuously changing, though direction is constant. If the velocity is changing, then we can say the motion is accelerated motion, means there is an acceleration in the stone, and this acceleration is arising due to the gravitational force exerted by the earth on the stone. So this acceleration arising in the stone, which is falling vertically downward, only in the influence, only is due to the gravitational force of earth, and this acceleration is only due to the gravitational force of earth and called gravity, denoted by small g. So in this situation, when an object is only under the influence, when an object is in motion only under the influence of gravity, only under the influence of gravitational force, then such a motion is regarded as free fall motion. It means in a simpler way, similar way, if we find out the expression for G, means you can say the relation between G and capital G. Then here, first of all, know here what is this G? This is acceleration due to gravity. Simply we say gravitational acceleration, simply gravity. So acceleration due to gravity is G. If we talk about the value of G, then its value comes certain constant. We will discuss about that later. But first of all, we should discuss about the SI unit of G, SI unit of the acceleration due to gravity. The SI unit of acceleration due to gravity is same as the SI unit of acceleration. So I think you all know the SI unit of acceleration is meter per second square. So SI unit of acceleration due to gravity is also meter per second square. So now I think now it is clear to you all that what is free fall and what is acceleration due to gravity are simply gravity small g. Now let's get the relation between small g and capital G. So suppose any object, this is mass, this is earth actually having mass me and its radius is re, its radius is re. Suppose at certain height any other mass, any other object of mass m is at a distance, is at a height h above the surface of earth, then in that case, we can say this object m, this object of mass m is experiencing an acceleration which is directed towards the center and due to the gravitational force exerted by the earth on this body. And if there is acceleration in this body at this height, then by Newton's second law we all can write F is equals m into g. By Newton's second law, which is ma, here a equals g, so force on this is m into g. Now if we talk about the force on this particle, on the same particle, by the universal law of gravitation, then we can write F is equals g mass of this, mass of earth, mass of this particle, mass of earth. And now the separation between mass of the object and mass of the earth from its center, which is re plus h, which is re plus h square, re plus h square. So if these two forces must be same, because they comes in the same way for the same body in the same situation, that's why we can write m into g equals g m me upon re plus h, re plus h whole square. So in this way, we can write here, we can eliminate small m, and we can write small g equals capital G me upon re plus h, re plus h. This is the relation between small g and capital G. In case if this body, this object of mass m is lying on earth's surface, in that case h becomes 0, means at earth's surface, h equals 0. In that case this relation becomes small g equals capital G mass of earth upon radius of earth square. So this is the expression which is to be noted, which is to be kept in mind. This is what the relation between small g and capital G. Now if you look the value of g, which is in terms of capital G, me and re, the right side of this equation we have all these things. G means this physical quantity capital G, this physical quantity me as well re, all these are constant. So if we place the value of capital G, mass of earth, radius of earth and calculate it, then average value of G we get, which comes 9.8 meter per second square. So the value of G, acceleration due to gravity, is 9.8 meter per second square. Now let's have a discussion about the variation of G due to the shape of earth. As here in this expression you can say, you clearly see that here in this you clearly see that if re plus h, or in this expression you clearly see that if re is varying, then in that case g also varies. Mass is not going to be varied because mass is a universal constant, but this mass of any object is a universal constant, means throughout the universe mass of any object never ever changes, but re can change. If re is changing, and you all know earth is not a perfect sphere, means then it is ellipsoid. Ellipsoid means एक अंडे जैसा. In that case, in case of ellipsoid, the major axis, this is major axis, this is minor axis. So the major axis, which is in case of earth, which is equator, and in case of minor axis, which is pole. So you can clearly you can see here, at the poles radius of the earth is lesser. If at the poles radius is lesser, then in that case g is greater. So poles पे अगर हम g की बात करें तो g की वैल्यू पोल्स पे ग्रेटर है. किससे ग्रेटर है? ग्रेविटेशनल फोर्स या ग्रेविटी की वैल्यू से. कहाँ पे? इक्वेटर पे. क्यों इक्वेटर पे? क्योंकि इक्वेटर पे अर्थ फ्लैटेंड नहीं है. इक्वेटर पे अर्थ नियरली मींस यू कैन से परफेक्ट सर्कुलर है. तो इस केस में यहाँ पे जो हमारा रेडियस है मैक्सिमम है. रेडियस का मैक्सिमम होने से यहाँ पे इनवर्सली प्रोपोर्शनलिटी हम देख पाते हैं जी और आर में. तो कह सकते हैं कि अगर आर ग्रेटर है तो जी लेसर है एंड वाइस वर्सा. सो इन दिस वे वी कैन से द वैल्यू ऑफ जी एट पोल्स इज ग्रेटर देन द वैल्यू ऑफ जी एट equator. So this is what we have to discuss in this lecture today. In the next class we will discuss the next thing. For today only this much you have to put, and also you have to remember the previous topic we studied before the holidays. So thank you.